So we're going to graph a system of inequalities. What it means is we're going to have we're going to have two equations. We're going to graph each. The reason I want you to have two colors is so that you can really see which shading part goes with which line. Okay? So we're going to graph it. We're going to shade. Then we're going to graph the second one, and we're going to shade. And then where they overlap, that's where we're going to make that shaded region darker, and that's where the answer is. And what I mean by that is, in those ordered pairs, we'll make both of the equations true at the same time. So we're going to do number one. So because this is less than or equal to, because there's an equal to there, it's going to be a dotted line. So I'm going to make this a pen. So this is going to be in blue pen. And then this is going to be a dotted line. That's going to be my pencil. Okay, and this is a dotted line because there's not an equal to. So we're going to start at positive 5 because that's our y-intercept. So positive 5. And then we're going to go down to 1, 2, to the right 1. Down 2, to the right 1. Down 2, to the right 1. And you guys, it is really important that especially in inequalities, because once we get to, I think that's down 2, that you make as many points as you possibly can. You want to get the best line possible, especially because when we go to make our triangles, we're going to need those vertexes to be really crisp. And what I mean by crisp is clear. I shouldn't say crisp, clear, that we actually can see them. You guys, I can also go up to the left one. And then I really want you to use a straight edge. You really need to use a straight edge to make this line as straight as possible. And also remember, this is a solid line because it's less than or equal to. Make sure your line goes completely through the coordinate plane. Now, let's shade. Let's talk about where we're going to shade. So we have this part of the line and we have this part of the line. So if I plug in 0 for y and 0 for x, is 0, so 0 for y, 0 for x. So 0 for y, 0 for x. Is that a true statement? Is 0 less than or equal to 5? Let's think about that again. Is 0 less than or equal to 5? So we're going to, 0, 0's here, so we're going to shade here. And just make it kind of light.
With the same color.
Yep, with the same color. So we know that's our line. Don't make it really dark, but you want to shade so you know. Now, we're going to graph the second line. And this line is going to be dotted because there's no equal to. And I'm going to start at negative 6. And then, you guys, can I go down 14? So instead of going down 14, I can go up 14 and then to the left. Okay, so we're going to go up 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? 14 and over to the left 1, correct? Do those lines intersect? Did you see that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I know, because because I couldn't see. I wanted to make sure I could count. Is it up here? Like above the arrow, right? Okay. And this is going to be a dotted line. Okay. Make sure you can make sure the dotted. Sorry about the graph, you guys. Okay, now I'm going to do the same thing. So I'm going to do the same thing. Since the line doesn't go through 0, 0, I'm going to test 0. So what that means is I'm going to plug in 0 for y, and I'm going to plug in 0 for x. Is 0 greater than -6? Is that a true statement? Because 0 is greater, because the -4 times the 0 cancel out. So 0 is greater than -6. I would shade this way above the line. And now, can you see where they would overlap? They would overlap in here. So we're going to make that as dark as possible. Because what's that saying is, in this area, anything in this area will make both of those equations or inequalities true at the same time. Now, inequalities are not consistent or inconsistent or any of that we learned in 3.1. So that is the region that makes both of the inequalities true at the same time. And you guys, just so you know, it is possible that if you graph these, that when you go to graph them, that they don't have anything in common, which means that none of the regions overlap. So it just means that they don't exist. I mean, they have an empty set. It's not that they don't exist. They just don't have a solution. Okay, you ready to graph number 2? Yeah. Okay. Y is greater than or equal to the absolute value of x. You guys, what type of graph is that going to be? It's going to be an absolute value, and what is it going to look like? It's going to look like a V. So you can make a chart. X's can be negatives, but Y's are going to be what? Positive. So if my X is -6, what is my Y going to be? So we're going to go up to +6. Okay, so I made my V, and is it going to be a dotted line or a solid line? It's going to be a solid because it has an equal to underneath it. Now, the problem with this one is I can't plug in 0, 0, can I? Yes. We can't plug in 0, 0 because the vertex is at 0, 0. So we need to plug in something else. Let's plug in -5, -5. Just because I can see that it's clearly on the outside of the absolute value. So I'm going to plug in -5 for the y, and I'm going to plug in -5 for the x. I always like to pick points that are exactly the same so I don't get the x and the y mixed up. That's why I do that. So you just have to remember where you plug the point in. So it's -5, 5, so it's on the outside of the absolute value. Is -5 greater than or equal to the absolute value of -5? Is that true or false? Is -5 greater than or equal to the absolute value of -5? This is false. So that was on the outside, so we're going to shade We're going to do a light shading on the inside of the absolute value. And again, you guys, I had picked -5, -5, and was on the outside here.
You just pick whatever point you want.
Yep. Pick any point that you want to plug into the equation. I always make sure the coordinates I pick are the same, so that way I don't forget which one I picked for y and which one I picked for x. Okay, now what we're going to do is we're going to graph y is less than 4/3 x plus 5. So where's my starting point? 5. Now, can I go up 4 and to the right 3? I can go right 3, but I can't go up 4. So I'm going to do the opposite, which is what? Down 4 to the left 3. So 1, 2, 3, 4, 1, 2, 3. Do it again. 1, 2, 3, 4, 1, 2, 3. Now, is this line a dotted or solid line? It is dotted because there's not an equal sign underneath it. Again, you guys make sure that your line goes completely through. And now we're going to test our point. And we can test 0, 0 because 0, 0 is not on the line. So is 0 less than 4/3 times 0 plus 5? So basically, is 0 less than 5? Just want to make sure. 0 is less than 5, so that's true. So we'll shade this way for the line. And then do you guys see where they intersect? Right here. So we're going to make this the darker region. This is my, like I said, this is the closest thing that you get to color in Algebra 2. So again, you guys, it is possible for two functions not to intersect, and that would just mean that they have nothing in common. I've seen two parallel lines where you shaded between the parallel lines. I've seen two parallel lines and you shade opposite and they have nothing in common. So it is possible to have an empty set. Does it happen a lot? No, but it does happen. Okay, are we good with that?